Hello everyone and welcome to Similar Triangles. Please copy these notes down. They're not in the worksheet that I gave you. Similar triangles, facts about congruent triangles. With congruent triangles, it's very important that you realize that corresponding angles are equal and corresponding sides are equal. So both of these with congruent triangles have equal angles and equal sides. On the flip side, when we have similar triangles, corresponding angles are equal. However, the corresponding sides are in proportion. So we learned about similar triangles already, but now they are going to have corresponding sides that are in proportion, as opposed to congruent triangles where everything is equal. So again, this is a common question on the regions. Corresponding sides are equal in congruent triangles, and corresponding sides are in proportion in similar triangles. So write that down and then let's take a look at the next page. The next thing here, we have the following. Are these triangles similar? Yes. Why? Because all the angles are congruent. So when I wrote all the angles are congruent, some of you might say, well, we only seem to see two angles that are congruent. And if you realize that there are 180 degrees in a triangle, if the two of these add up to 100, then this last angle must be 80. And in this case, if two of the angles add up to 100, then this last angle must be 80 as well. So I would do 3 swooshes there, 3 swooshes there, and you'll realize that to prove two triangles similar, you technically only need to show that 2 angles are congruent, because if 2 angles are congruent, that implies that the third angle is congruent. Let's take a look at the next page. This is the proof that you have. So we're going to start with AB perpendicular to AE. We're going to label that with a 1 and a right angle. DE perpendicular to AE and a 2 with a right angle. Then it also tells me that BCA, which is this one, is congruent to DCE, which is this one. So we'll call that 3 and 4. And then I'll show you how we're going to prove that the triangles are similar. By the way, this is the symbol for similar. So when you see that, you should know that we're looking to prove similar. Like I said before, the only way to prove similar is to show that angle-angle is congruent to angle-angle. So let's take a look at the proof. Here's the proof, and this is what it looks like. So the first statement given. Second statement, angle 1 congruent to angle 2. Perpendicular lines intersect to form congruent right angles. Number 3, given. And number 4, simply that the triangles are similar based on angle-angle. That's all you have to do for this proof. So please make sure you copy that down, and then you can go to the next slide. In the next slide, we are looking at, it says AB is parallel to DE, so to remember to label parallel, we're going to do arrows. Automatically, that implies that this angle 1 is congruent to this angle 2 based on alternate interior angles. And now we're trying to prove that the two triangles are similar, so we know we have to use angle-angle, and it seems as though I'm short. So one of the things that you should look for when you're short is reflexive or vertical. And in this case, I actually have vertical angles. So I'm going to call those 3 and 4. And then you can simply write out the proof. So let's take a look. This is what it's going to look like. The first one, I think everybody already knows that angle 1 is congruent to 2. If 2 parallel lines are cut by transversal, then the alternate interior angles are congruent. After we write the given lines being parallel, then we're going to go to 3 and 4. So these have 2 swooshes on them. These have 1 swoosh on them. So we're going to go 3 is congruent to 4 from vertical angles are congruent. And now we're totally done. The triangles are similar based on angle-angle. You will find that these similar triangle proofs are, in the beginning, a lot easier than congruent triangle proofs because you only need two pieces of the puzzle. Let's take a look at the next one. So in this case, it says BC is perpendicular to CA. We're going to label that 1 with a right angle, and this is going to be 2 with a right angle. Now, it seems again as though we're short. So when we're short, we look for reflexive or vertical. There are no vertical angles in this picture. However, there is a reflexive piece right here. Angle 3 is actually in both triangles. It's in the large triangle and it's in the small triangle. So we're actually going to use reflexive, and then we will have the angle that we need. So let me show you how that's written out. So we start with the givens. BC perpendicular to CA, DE perpendicular to CA, given. Perpendicular lines intersect to form congruent right angles. Then we go to the reflexive property. Angle 3 is congruent to angle 3. And the last thing, that the triangles are similar. Please make sure that you're using the similar symbol right here, a similar symbol right there, and you want to use a congruent symbol right there. So similar here, congruent there. Everybody clear on that? Make sure you use similar in the statement and congruent in the reason. Let's take a look at the next one. So then, we have the following. We're going to label that these are right angles. They kind of don't really look like right angles, but let's just go with it because it says that they are perpendicular. Then this one, it says that angle ABF, which is this one on the outside, is congruent to GDE, which is this one on the outside. So we're going to go 3 and 4. Automatically, that implies that this angle on the inside, 5, is going to be congruent to 6 based on linear pairs. And then we have the angle that I needed to prove similar triangles. So let's take a look at what the proof looks like. We're going to start with the givens, so perpendicular lines, and they intersect to form congruent right angles. Then we're going to go the whole linear pairs are supplementary, and supplements of congruent angles are congruent. We've talked about that as the exterior angle theorem. And then the last one, we're going to say that the triangles are similar based on angle. So please make sure you copy all these proofs. If you need to rewind or pause, do so. And thanks, and I'll see you tomorrow.